Today's session is about formation of partial differential equation by elimination of arbitrary function from their relations. Approach: check for the arbitrary functions. F is a function of uv, u is a function of xyz, and v is a function of xyz. Then differentiate the equation partially with respect to x and partially with respect to y. Find p, q, and r. P is Jacobian uv with respect to yz is given by this. Jacobian q is equal to Jacobian uv with respect to zx, which is given by this. R is equal to Jacobian uv with respect to xy, which is given by this. Solve using formula pp plus q is equal to r. The resultant is the first order linear partial differential equation of the form this. Let's understand clearly with an example. Here, this is the function. So, function, it's a function of u and v. So, u is equal to x plus y plus z, and v is equal to x square plus y square minus z square. Now, we have to find p, q, and r. P, we will be finding P with the help of this. Here, dou u by dou z, that is a differentiation of u with respect to y. When we differentiate u with respect to y, x and z will be constant, and differentiation of y will be 1. Now, dou u by dou z. So here, differentiation of u with respect to z. So these two terms will be constant, and differentiation of z is 1. Next is dou v by dou y. Differentiation of this with respect to y. So other two terms will be constant, and this will be 2y. Then dou v by dou z. That is differentiation of this with respect to z. So here x and y will be constant, and so differentiation of this constant will be 0, and differentiation of minus z square will be minus 2z. Now cross multiply this, we get minus 2z minus 2y. Let's calculate q. Q is equal to dou u by dou z. So differentiation of u with respect to z is here 1. Here dou u by dou x. So differentiation of u with respect to x is 1. Dou v by dou z is a differentiation of v with respect to z is minus z square, so minus 2z. So dou v by dou x. So differentiation of v with respect to x is 2x. Now cross multiply. This is 2x minus of 2z will be this. Now calculate r. So here dou u by dou x. So differentiation of u with respect to x. This term will be constant, so differentiation will become 0. So differentiation of x is 1. Dou u by dou y. So here differentiation with respect to y. So these two terms will be 0, and differentiation of y is 1. Dou v by dou x. Differentiation of this with respect to x. These two terms will become 0, and x square will be 2x. Dou v by dou y. Differentiation of y with respect to differentiation of v with respect to y. So these two terms will become 0, and this y square will be 2y. Now we have to cross multiply these two and these two. So 2y minus 2x. Now we have to put the value of p, q, and r in this equation. So after putting the value in the equation, we see 2 is common all over, so we can cancel it out and change the sign throughout the equation and simplify it. We get this. Simplifying further, we get this, which is required partial differential equation. Let's take another example. So this is the function. So f is equal to function of u and v. So here u is equal to x square plus 2yz, that is u, and v is y square plus 2zx. This is v. Now we have to find P, Q and R. So P is equal to this. We have to we'll start differentiating it. Here, dou U by dou Y. So differentiation of this with respect to Y. So this term will become 0. Differentiation of Y is 1. Y 1 into 2Z is 2Z. Now differentiation of U with respect to Z. So partial differentiation of U with respect to Z will be, this term will become 0 and we'll get 2Y. Now the partial differentiation of Y with respect to Y. Partial differentiation of V with respect to Y. So when we differentiate partially this value of V with respect to Y, this term will become 0 and Y square will become 2Y. Now partial differentiation of V with respect to Z. So when we differentiate this with respect to Z, this term will become 0 and Z, differentiation of Z is 1, so we get 2x. Now cross multiplying it and subtracting. So 2z into 2x is equal to 4xz minus these two multiplication. 2 into 2 is 4 and y square. Now we shall calculate q. Q using this. So dou u by dou z. So differentiation of u with respect to z. When we differentiate this with respect to z, this term will become 0 and differentiation of z is 1, so we get 2y. And differentiation of u with respect to x, so this term will become 0, x square will become 2x. Here v with z, so partial differentiation of v with respect to z will be, this term will become 0 and the differentiation of z is 1, so we get 2x. Differentiation of v with respect to x, so this term will become 0, differentiation of x is 1, so we get 2z. Now cross multiplying it, 2 into 2 is 4yz minus 4x square. Now we have to calculate r. Dou u by dou x will be differentiation of u with respect to x, so it will be 2x. Partial differentiation of u with respect to y will be 2z. Partial differentiation of v with respect to x will be 2 partial differentiation of v with respect to x. So here partial differentiation of v with respect to x will be, this term will become 0 and this differentiation of x is 1. So 1 into 2z is 2z. Similarly, partial differentiation of v with respect to y. Here this term will become 0, y square will become 2y. Now cross multiplying it, we'll get this. Now substitute the value of p, q, r in the equation. We get this. Here 4 is common throughout, so it get cancelled. And changing the sign and simplifying it, we get this. And this is the required partial differential equation. Here in this example, this is given and f uv is equal to 0, u is equal to x square plus y square plus z square, v is equal to z square minus 2xy. Now we have to find the value of p, q and r. So dou u by dou y, that is partial differentiation of u with respect to z. With respect to y. Here x and z term will be considered as a constant and they'll on differentiation it will become 0. Y square on differentiation becomes 2y. Dou u by dou z. Now partial differentiation of this with respect to z will be, this two term will become 0 and z square will become 2z. Now dou v by dou y, partial differentiation of this term with respect to y. So this term will become 0 and partial differentiation of y is 1. 1 into minus x minus 2x is equal to minus 2x. Here dou v by dou z. So partial differentiation of v with respect to z. Here d- z square when differentiated it becomes 2z. Now cross multiply and subtract. So we get 4zy plus 4xz. Now q is equal to dou u by dou z, that is differentiation of u with respect to z, is z square will become 2z. Dou u by dou z, differentiation of u with respect to x. So these two terms will become 0 and x square is 2x. Now differentiation of v with respect to z. So partial differentiation of this expression with respect to z is 2z. Now dou v by dou x, partial differentiation of v with respect to x. So this term will become 0. Differentiation of x is 1. 1 into minus 2y is equal to minus 2y. Now we have to multiply these two, cross multiply and then subtract. So these two on multiplication will become minus 4y. Here this is minus 4xz. R. Now we have to calculate R. Dou u by dou x, we know it is 2x. Dou u by dou y is 2y. Dou v by dou x, that is differentiation of partial differentiation of v with respect to x. So this term will become 0. So here differentiation of x is 1. 1 into minus 2y is minus 2y. Dou v by dou y. So differentiation of this with respect to y. So differentiation of y is 1. So 1 into minus 2x is minus 2x. Now we have to cross multiply this and subtract. So cross multiplying this is minus 4x square minus of this is plus 4y square. Now substitute the value of p, q and r in the expression. pp plus qq is equal to r. So here capital P value is this, p plus q value is this, and r is here this. Here in this equation 4 is common and it can be cancelled. Now we get this. On simplifying it, we get this. Further simplification of this, we get this, and this is the required partial differential equation.